Good morning. I hope everybody's doing well today. So today is just going to be mostly focused on review. We'll see how long it takes us to get through that. If we have enough time, then I'll get started on chapter three. But we'll kind of play it by ear, see how long it takes us to actually get through all the problems in the review. This test is a little bit longer than the first test. So even if you were able to do the first test rather quickly, I would say just make sure you're budgeting enough time for yourself. Right, you have the 2 hour window. It may still not take you the full 2 hours, but I do think it might take you a little bit longer than the last test. So just plan on that. Okay. All right. Other things, don't forget that tomorrow night by midnight, the homework on section 2.8 is due. So make sure that you set aside some time to get that done. The test will open at midnight tonight, and that will be due Friday at midnight. Okay. So again, just find a couple hours, Thursday or Friday, to make sure you take the test and get that submitted by midnight Friday night. Okay. I've already moved the first sections of chapter 3 homework to Monday of next week. And again, I'll adjust that as needed if we still need even more time than that. Okay, but for right now, the earliest it'll be due is Monday at midnight. Any questions, comments, concerns about anything before we get started on the review now? All right, and just bear with me. My voice is a little raspy today. I was at the Carolina Hurricanes game last night, so I yelled a little bit too much, but we'll get through this. So, number one, we want to find f prime of x using the limit definition of a derivative. So, first things first, we need to know that limit definition of a derivative. You have to memorize it, so make sure you've got that memorized before you sit down and take your test. So, the first step, we've got limit h approaches 0. What's going to go in our numerator here? So what's the first thing? Let's just look at the formula first. What's the first thing we're going to have to find in this case if we're using our limit definition to calculate it? Good, right? So the numerator is going to be f of x plus h minus f of x. And then our denominator is just going to be h. Perfect, right? So that's the formula that you need to make sure that you have memorized. So limit as h approaches 0, f of x plus h minus f of x all over h. All right. Now we're going to substitute everything in there that we know. Okay, so if we're looking for f of x plus h, we're just substituting that into our function over here. So that's going to become x plus h to the third power plus 5 times x plus h, and then plus 4. And then we're subtracting f of x. Okay, so just make sure you're subtracting the entire function here. X cubed plus 5x plus 4. Again, all of that is over h. Any questions up to that point? All right, now if we simplify this, we've got x plus h to the third power. So what is x plus h cubed going to give us? Good, right? And so if you just remember this, you can go ahead and do it this way. If not, you can actually do x plus h times x plus h times x plus h, work it all out, right, and combine like terms. This should give us x cubed plus 3x squared h plus 3x h squared plus h cubed. All right, and then we can distribute the 5 here, so that's going to give us plus 5x plus 5h plus 4. And then down here, don't forget, we've got to subtract everything. So distribute the negative. So we get a minus x cubed, minus 5x, and a minus 4. All over h. All right, now it's just a matter of combining like terms. So if we do that, what's going to be left in our numerator now? Good. So those are the 4 things that are left, right? So we have the 3x squared h plus 3x h squared plus h cubed plus 5h. Because the x cubed minus x cubed cancels out. We have the 5x minus 5x cancels out. And then the 4 minus 4 cancels out. All right. All of that's over h. And factor out the h. Good. We'll do that. That'll give us 3x squared plus 3xh plus h squared plus 5. Okay. All right, now we can cancel out that h. Perfect. And now we're just looking for the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 5. And if we substitute in 0 here, notice this is where h is approaching 0, so only put the 0 where the h's are. We're going to have 3x squared plus 3x times 0 plus 0 squared plus 5. And if we simplify all of that, what are we left with? Just 3x squared plus 5. Right, now, since we know the shortcuts, right, we can actually find the derivative of that one just using power rule pretty quickly. And you can see that that should give us 3x squared plus 5. So you can check your answer really quick that way, but make sure that if it tells you limit definition, that you're using that limit definition of a derivative to calculate it, okay? Any questions on that one? All right, let's take a look at number 2. We just want to calculate y prime. All right, so if we look at this first one, how are we going to find y for part A? All right, good. First step, let's go ahead and rewrite this. X squared minus x plus 2 over x to the 1/2 power. Anytime you've got a root like that, go ahead and change it to a fractional exponent. All right, now what do you want to do? Okay, we could do a quotient rule, right? That's one option. You could also simplify this fraction first, okay, and do it that way if you want to. So it's kind of up to you. Simplifying it, I think, makes it a little bit easier to calculate the derivative. But if you do quotient rule, you'll get exactly the same answer. All right. So if we were to simplify this, and so I was saying bring it up, right? We can actually bring this up as x to the negative 1/2 times everything in the numerator. And then we can actually distribute that to each of our terms. So if we do that now, x to the negative half times x squared, we would add those exponents. It's going to give us x to the 3/2 power minus x to the negative 1/2 times x to the first power. Again, add those exponents. That's going to give us x to the positive 1/2 plus, and then now 2 times x to the negative 1/2 is just 2x to the negative 1/2. Now that we have that, now what can we do to calculate that derivative? Just power rule, right? And so if we use our power rule, y prime is going to be equal to 3/2 x, subtract 1 from that, that's going to give us 1/2, minus, bring down the 1/2, x, subtract 1 from the exponent, that's going to become a negative 1/2, plus negative 1/2, which times a 2 is going to actually give us a negative 1, so this becomes a minus x, and subtracting 1 from that exponent gives us a negative 3/2. Now, we typically don't like to leave negative exponents, right? And so in this case, you would want to move those to the denominator. And so for this one, we would have 3/2 x to the 1/2. That one's already positive. We're good. Here, when I move this to the denominator, the 1 stays up top. 2 is already in the denominator. And then we get x to the 1/2 down here, minus. In this one, we don't have any coefficient, so there needs to be a 1 in the numerator. And then x to the 3/2 in the denominator. And we can leave our answer just like that. Now, if you were to do quotient rule, just know what's going to happen is you're going to actually end up with a single fraction as your answer. If you were to find a common denominator here and combine all of these, it would match exactly what we get with rule. Okay, but either one of those would be perfectly acceptable, right? So if you see ways to simplify that make the derivative easier to calculate, by all means use that, right? But if you see this as a quotient rule and want to do it that way, that's fine too, right? Either way, I'll accept either one of those answers because they are equivalent, okay? Any questions on that one now? And if you want to see the quotient rule way, just take a look at my solutions for the practice test. I did quotient rule on that one and showed you how to simplify it and everything. All right, let's take a look at B. So what are we going to have to do to find the first derivative for B? Good. This is going to be a product rule, right? So the first step is we've got to identify f and g. There's no other way to do this one because we can't simplify it first. So what are we going to let our f function be this time? Good. X squared is going to be our f, which means g is going to be everything else. So sine of pi x. All right. Now we need the derivatives of each. So what's f prime going to give us? Good. That's just 2x. And now g prime, what are we going to do? Okay, it's going to be cosine, right? Because that's the derivative of sine. But what rule are we going to have to use here? It's technically a chain rule, right? Because we have more than just an x inside. We have a pi times x. What's the derivative of the inside here, though? Just pi, right? Because that's the coefficient of your x. So this is going to be cosine of pi x. And then we multiply by the derivative of the inside, so we just multiply by pi. Now, if you need to, right, you can actually show the work where you change this to sine of u, where u is equal to pi x. u prime is equal to pi. This becomes cosine of u times u prime. So that's cosine of pi x times pi. But if you can do it without showing that work, that's fine too. All right, now we have all the pieces. Y prime equals, remember for product rule, it's going to be f g prime plus g f prime. Make sure you know these rules, right? Quotient rule, product rule, chain rule, because those formulas aren't given. Okay, so you need to know what they are. Now, if we go back over here, we're going to start with f, so that's x squared times g prime, which is cosine of pi x times pi, plus, then we take our g function, sine of pi x, multiply that by f prime, 2x. I would say no sine, cosine, and tangent just to be safe. Okay, so remember sine gives you cosine, cosine gives you negative sine, tangent's going to be secant squared. If you know those three, you should. Okay. All right. Now, at this point, right, that answer is actually fine, right? If you want to move things around, that's fine too. So this is y prime equals, I'm just going to bring the pi out front as a coefficient. So we get pi x squared cosine of pi x plus, and then I'll do the same thing with the 2x, move it out front. So 2x sine of pi x. But again, if you stop at the line before that, that's technically simplified, right? There's nothing wrong with that answer. We just typically put our coefficients out front. Any questions on that one now? All right. Number 3, implicit differentiation. We're trying to find dy dx. Okay, now, if you write y prime instead of dy dx, I'm fine with that too, just so you don't have to write dy dx over and over again as you're calculating these derivatives. Okay, so feel free to use y prime. All right, so if we look at a here, what are we going to have to use for the first term, x y to the fourth, to find that derivative? Okay, so it's going to involve chain rule, right? And it's also going to involve what rule? We have x, y to the fourth. Okay, power rule technically because of the y to the fourth, but what are we doing with the x and the y to the fourth? It's a product, right? Okay, so make sure you recognize here x times y to the fourth is a product, so we're going to have to use product rule to actually calculate this derivative. So the first step, I'm going to come over here and do this. We're going to let f be x, and g is going to be our y to the fourth. So anytime you see multiplication like that of two functions, right, in this case just the x and the y to the fourth, just make sure that you're actually thinking of those as a product rule. Now, what's our derivative for x going to give us? That's just 1, right? Because we're taking the derivative with respect to x, so we just get a 1. And over here for g prime, that is going to give us what? 4y to the third y prime, right? So don't forget now, because we're taking a derivative with respect to x, anytime you take the derivative of a y term, we have to have that y prime. All right. Now, product rule, again, we start with f. So we're going to get x times g prime, which is 4y cubed y prime, plus, then we're going to have our g function, which is 1 to the 4th, times f prime. In this case, that's just 1, though. So that just takes care of x y to the 4th. That's our derivative for that piece. Now, what are we going to have to do for x squared y? Same thing. It's another product, right? So I'm going to come over here. This time we're going to say f is x squared. Our g function is y. So f prime is going to give us what? 2x. Good. G prime is going to be what? Y prime. Perfect. All right, so now we're going to end up with x squared is our f. Multiply that by g prime, so that's y prime. Plus, then we take our g function, which is y, multiply that by f prime, which is 2x. All right, so that's the left-hand side. Any questions up to that point? Yes. Let me fix that so it's a little clearer. So this is just times 1. Okay. All right, let's look at the right-hand side now. So what's the derivative of x going to give us? That's just 1, right? So that one's pretty basic. And then the derivative of 3y would give us what? 3y prime. Perfect. So since there's no multiplication, division, anything like that, right? These are straight power rules technically, right? But there really isn't even an exponent we have to deal with. All right, now that we have all of that, what are we going to do next? Good. We need to get y prime by itself. Well, notice we've got 1, 2, 3 different terms that have a y prime in them. So we're going to have to get all those to one side first. So I'm going to go ahead and just kind of rearrange some terms here first just to simplify it, and then we'll get all the y primes together. This is going to be 4xy cubed y prime plus, this is just going to be y to the 4th plus x squared y prime plus 2xy equals 1 plus 3y prime. All right, so now I'm going to move my y primes to the left here. So I'm just going to go ahead and subtract 3y prime from both sides. We'll have 4xy cubed y prime plus y to the 4th plus x squared y prime plus 2xy minus 3y prime equals 1. Now, anything that doesn't have a y prime, I'm going to move that to the right-hand side. So I'm subtracting the y to the 4th, and I'm subtracting the 2xy here. So we'll have 4xy cubed y prime plus x squared y prime minus 3y prime. Now, on the other side, we're going to have 1 minus y to the 4th and minus 2xy. Just take your time with those steps, right? If you can move them all at the same time, right? All the y primes to one side and everything else to the other side, that's fine. Just be careful with the signs, especially as you move those things around. Now, at that point, what can we do? Good. Now we can factor out the y prime on the left-hand side. That leaves us with 4xy cubed plus x squared minus 3. Everything on the right-hand side stays the same. And then our last step is to do what? Good. Now we can just divide everything here. So we're going to have y prime equals 1 minus y to the fourth minus 2xy all over 4xy cubed plus x squared minus 3. Again, if you happen to move your y primes to the right and everything else to the left, all of those signs would be the opposite of what they are here. Perfectly fine. And then the order of the terms in the numerator and denominator don't matter either, right? So if you had those switched up, that does not matter. Any questions on part A now? All right, let's take the differentiation. We need to find y prime or dy dx. So if we look at that first part, x squared cosine y, what are we going to have to use to find that derivative? The product. Good. So again, I'm going to come over here. I'm going to let f be x squared. We'll let our g function be cosine of y. So what's our f prime? 2x. Good. And g prime should give us what? Negative sine y, y prime. Good. So the derivative of cosine is negative sine, but because we're taking the derivative of a y term, we have to remember that y prime here. All right, now using our product rule, start with f. We're going to have x squared. Multiply that by g prime, so that's negative sine y, y prime. Plus, we take our g function, cosine y. Multiply that by f prime, which is 2x. All right, so that takes care of that first term. Now we need the derivative of sine of 2y. How are we going to find the sine of 2y? It's a chain rule. Good. So the inside here is going to be 2y. So if you want to write that out, this is going to become sine of u, where u is equal to 2y. What's the derivative of 2y going to give us? Good. 2y prime. What's the derivative of sine of u going to be? Cosine u. Because it's a chain rule, we have to multiply by u prime. Now we just substitute back in. We get cosine of 2y times 2y prime. And again, if you can do that chain rule in your head without writing out the steps over there, perfectly fine. Okay, but if you need the u substitution piece, please use it so that you don't get confused. All right, so now we're going to get cosine of 2y times 2y prime. And that's our left-hand side. Now how are we going to find the derivative of the right-hand side? It's a product again, right? So we have x times y. So again, f is going to be x, g is going to be y. I'll just go ahead and do these. Derivative of f is 1. Oops, this should just be y. So the derivative of g is going to be y prime. So again, using your product rule here, that's going to be f times g prime, so x, y prime, plus, and then g times f prime is just going to be y times 1. Any questions just on finding the derivative of each piece of that? Okay, so let's go ahead and I'm going to clean it up first, and then we'll move terms around. So here I'm going to get a negative x squared sine y, y prime, plus I'm going to bring my 2x to the front of this term, so 2x cosine y. Down here, bring the 2 out front, so 2 cosine 2y, y prime. Other side is just going to be x, y prime plus y. Now, just like the previous part, right, we're going to move all the y primes to one side, move everything else to the other side. I'm going to move all the y primes to the left here, so we'll get negative x squared sine of y, y prime, 2x cosine y, 2 cosine 2y, y prime, minus x y prime equals y. And then my only term that doesn't have a y prime on the left is the 2x cosine y, so I'll move that to the right. Right, and at that point, again, same thing, we're going to factor out the y prime. If we do that, we have negative x squared sine y plus 2 cosine 2y minus x. Right-hand side does not change. And again, just like the previous one, now we can divide by everything in parentheses to get y prime by itself. We have our y minus 2x cosine y in the numerator over negative x squared sine y plus 2 cosine 2y minus x in our denominator. Any questions on part B now? So again, just keep in mind, key to these problems, make sure you recognize when you have a product, when you have a chain, things like that. And also remember that anytime you're taking the derivative of a y term, you have to have that y prime as part of that derivative. All right, let's look at number 4. So we want to find the equation of the tangent line and the normal line to this curve at the point 0, 1. All right, so if we're looking for, let's start with tangent line. What's the first thing we're going to need to do? Good. We need the derivative, right? Okay, so to find the derivative, what should we do with that function first to help us find that derivative? Good. So I'm going to change my square root to a fractional exponent. This just becomes 1 plus 4 sine x raised to the 1/2 power. Now, to find the derivative, what are we going to have to do? Okay, good. It's going to be a power rule with a chain rule because there is an inside function here. So if you want to do a u substitution, we'll just let u be everything on the inside here. So 1 plus 4 sine x. I'm going to rewrite this as just u to the 1/2 power. What's our y prime going to be just in terms of u now? Okay, so the derivative of u, right, if we do that part, that's 4 cosine x. Good, that's our u prime. And now what's our y prime going to be in terms of u? Good, right, so bring down the 1/2, take 1 away from our exponent, that gives us a negative 1/2. Don't forget, because it's the chain rule now, have to have the u prime. Good. All right, now we have all the pieces we need, just plug them back in. So we've got y prime equals 1/2 times 1 plus 4 sine of x to the negative 1/2. And then we're multiplying that by 4 cosine x. All right, now at that point, right, we want to simplify first and then we'll go from there. So we have a 4 and we have a 1/2. We can actually multiply those together. 4 times 1/2 is just going to give us 2. Cosine x is going to stay in the numerator. Everything in the parentheses is being raised to the negative exponent. That's going to go to the denominator. We're going to end up with 2 cosine x up top over 1 plus 4 sine x to the 1/2 in the denominator. Any questions on finding that derivative now? All right, now that we have the derivative, what do we need to do next? Okay, good. We have an x value from our point up here, so we need to substitute that in because that's going to give us what? The slope, right? We're looking for the slope of our tangent line, so we have to substitute that x value in to get it. So this is going to give us m equals 2 cosine of 0 over 1 plus 4 sine 0 to the 1/2 power. Okay, now, if we simplify that, what's the numerator going to give us? Okay, 2 times 1, right? So cosine of 0, remember, is 1. So we get 2 times 1, which is just 2 in the numerator. Denominator now, sine of 0 is what? 0, right? So this just becomes 1 plus 4 times 0 to the 1/2 power. So really, that's just 1 to the 1/2. So the denominator is what? Just 1, because that's the square root of 1. 2 times 1 up top is going to give us 2. And now 2 over 1 gives us a slope of 2. right, so this is our slope of our tangent line now. All right, now that we have our slope, now what are we going to do? Now we can put it in point slope form. Good. So we're going to take y minus the y value that's given in the point up here. So that's 1 equals our slope, which is 2 times x minus 0. Again, that answer's fine, right? If you want to stop right there, if you want to get it in slope-intercept form, you would distribute the 2, move the 1 over. That would give you y equals 2x plus 1. Either one of those is perfectly fine for the tangent line. All right, now we need the normal line. What do we know about the normal line? Good. The slope is going to be the opposite reciprocal of whatever the slope for the tangent line was, because they have to be perpendicular. So I got to flip it and I got to change the sign. So our slope here is going to be a negative 1/2. So reciprocal of 2 is 1/2. Take the opposite sign, that makes it negative. Negative 1/2 is our slope. Now that we have the slope, we're going to do the same thing we did to find the equation, use point slope form. So this is going to be y minus 1 again. This time, though, we're going to get negative 1/2, and then x minus 0. And that answer's fine. If you want to put it in slope-intercept form, though, distribute the negative 1/2, move the 1 over. This time, that's just going to give us y equals negative 1/2 x and plus 1. And we're done, right? So first step, right, if you're looking for the equation of a tangent line in general, find your derivative. That will give you your slope. Plug in whatever point they give you so that you can actually find the numerical value of that slope. And then once we know the slope and a point, then we can use point slope form to find the equation of the tangent line. And then for the normal line, only difference, slope should be perpendicular. So we take the opposite reciprocal, and that gives us negative 1/2 in this case for our slope of our normal line. Any questions on number 4 now? All right. Number 5. So we have a particle that's moving on a vertical line, so that the coordinate at time t is given by this function. Okay, so y equals t cubed minus 12t plus 3, where t has to be greater than or equal to 0 because we're talking about time here, so we're only thinking about positive values for time. All right, so first thing, we want to find the velocity function and the acceleration function. So if we're given this original function, that's going to represent our position of our particle along that vertical line. How are we going to find velocity? Good. First derivative of position should give you the velocity. So we're going to say velocity is just equal to y prime in this case. All right. What would our first derivative give us if we take the derivative of y? Good. So first term here is going to give us 3t squared, just using our power rule. And then minus 12t is just going to give us a minus 12. Derivative of the constant, the 3, is just going to give us 0. So there's our velocity function. How are we going to find the acceleration function? Second derivative. Good. Take the derivative of velocity. We're looking for y double prime in this case. What's that going to give us? Good. Just 6t. Again, we're just using our power rule there, and the derivative of 12 is just 0. So that's it for part A, right? So just finding the velocity and acceleration functions. Just remember velocity is the first derivative, acceleration second derivative. Any questions on part A? All right, now part B. We want to know when is the particle moving up and when is it moving down. How are we going to figure that out? All right, so what are we going to be setting equal to 0 here, though? Good. The first derivative, which represents velocity, because if the velocity is positive, it would be moving which direction? Up. And then when the velocity is negative, then it would be moving down. So if we can figure out where it's equal to 0, that's where it's going to switch direction, and then we can figure out which side is up and which side is down. Right, so I'm going to take my first derivative here, 3t squared minus 12. I'm going to figure out where that's equal to 0, because that's the turning point. How would you solve that? Okay, add 12. 3t squared equals 12. Then what? Good. Divide by your 3, t squared equals 4. And that means our t value is going to be what then? Okay, good. And in this case, we know t has to be greater than or equal to 0, so we don't have to worry about plus or minus, right? We're only worried about the positive value. If you use Desmos for that part, that's fine, right? If you just want to figure out where it's equal to 0 by finding the x-intercept on the graph, I'm fine with that. Okay. All right. Now that we know that that is our turning point, how are we going to figure out where it's moving up and where it's moving down? Good. We can do some test points to figure out where it's positive and negative. And again, if you're using Desmos and you just look at the graph and see where is it positive, where is it negative, I'm okay with that too. But I'm going to put 2 on here. Okay, so if we choose a point to the left now, what value do you want to test? Okay, 1 works. All right, so we're substituting that in now to this derivative, okay, because this represents our y prime, to figure out is it positive or is it negative. So we're going to have 3 times 1 squared minus 12. So what's that going to give us? Negative 9, right? All we care about here is the sign. So on this side, everything's going to be negative. Now we need a value outside of 2. What's the value over there? 3. Good. We do 3 times 3 squared minus 12. What's that going to give us? Should be 15. Again, all we really care about is whether it's positive or negative. That side's going to be positive. All right, so now we just need to determine where is it moving up, where is it moving down. So where would this be moving up? Okay, good. Everywhere that x is greater than 2, right? So if you wanted to write it, you'd say x is greater than 2. Or if we want to use interval notation, what would that interval notation look like? 2 to infinity. Good. So from 2 to infinity. That's where the particle is moving upward. Where is the particle moving downward then? Good. Since t has to be greater than or equal to 0, we would say that it's moving down from 0 to 2. And if you put parentheses instead of there, right, technically at time t equals 0, we don't really know exactly what it's doing. Okay, so parentheses there is fine, or brackets fine also. Okay, but just make sure starting from 0 up to 2, we're moving in a downward motion. That's where it switches direction. And then from 2 all the way to infinity, that's where it's going to be moving up. Now, just to give you an idea, right, of what Desmos looks like for this one, just so it's an option if you want to use Desmos for this. Our velocity function this time was 3t squared. I'm going to call that 3x squared minus 12. We can see here the x-intercept at 2. Everything to the left of that is in the negatives. Everything to the right of that's in the positives. That's why we're moving downward from 0 up to 2, and then we're moving upward beyond that point. Okay. Again, if you want to use Desmos, right, I'm fine with that, because if you can use Desmos to find the x-intercept of the velocity function and then tell me, okay, everything to the right of that is positive, therefore it's going up, everything to the left of that is negative, therefore it's going down, you understand what you're doing, right? Okay, so that's all I'm really looking for here is, do you understand how to use that velocity function to find the intervals where it's moving up and down? Okay. Any questions there now? All right. All right. Part how to find the distance that the particle travels in the time interval from 0 to 3 seconds. How are we going to find that distance? Okay, so how would you find a distance in general? So what would be your process? If you want to know how far something has traveled, how would you measure a distance? All right, so that slope, that's going to give us a rate, right? So if we do y2 minus y1 over x2 minus x1, that's giving us a rate of change of something. I just want to know how far something has traveled. How would you calculate a distance that something has traveled? Okay, so we don't have to, I mean, it's going to involve time to figure these things out, right? But just in general, right? If let's say you're out in the yard, you throw a ball, and you want to know how far it went. How would you measure it? What would you do? What information would you need to know to calculate that distance? starting point and ending point, right? That's all we care about, right? Because if I'm looking for how far something traveled, I need to know where it started, where it ended up. So, same thing here. We want to figure out where did we start, where did we end up? Well, which function is going to help us to calculate that? The original, right? Because the original represents the position of the particle. So we want to figure out where did we start, where do we end up? Now, there's one little thing that we have to be careful of here. Since we're looking for the total distance, we have to factor in the fact that this thing might be changing direction, right? Well, we know for sure that it does because we saw that in part B. So we know it changes direction when? 2 seconds, right? So at time t equals 2, we know it changes direction. So when we find our distance now, we're going to have to look for the distance from 0 to 2 seconds. Then we're going to look at the distance from 2 to 3 seconds, and then we're going to put those together. Okay, so we can't just find the distance all the way from 0 to 3 because we're missing that turning point if we do that. We go from 0 to 2, and then we go from 2 to 3. That's the only little caveat we have to remember here. So what I'm going to do, I'm going to copy my formula down here. So that was t cubed minus 12t plus 3. Dean, yes, we could if anybody actually knew what that was, right? So at this point now, if we want to find this distance that we've traveled, we're going to substitute in our time at t equals 0. We're going to substitute our time at t equals 2. And then we're going to find the distance between those 2 points. All right, so I'm going to plug in 0 first. So we get y equals 0 cubed minus 12 times 0 plus 3. What's that going to give up for our initial position here? 3, right? I'm going to do the same thing with 2. So we get 2 cubed minus 12 times 2 plus 3. Okay, so that's the beginning. We get 8 minus 24 is negative 16. 16 plus 3 plus 8. All right. Now just find the distance between those two values. Right? How would you find the distance between our starting 3 and negative 13? How do you mess up? All right, give me 1 second. Let me. All right. Is that audio better now? Good. All right. Perfect. All right. So at this point now, we know our starting position is 3. We know at 2 seconds we're at negative 13. How are we going to find the distance between those 2 points now? Okay, so the problem with just adding them, right, is one's negative, one's positive, right? In general, if I want to know the distance between 2 points, what would I actually do with them? Like if I want to know how far is it from 5 to 8, what would I do with those two values? Subtract right? Because to find the distance between those 2 points, 5 and 8 on the number line, 8 minus 5 would give us a distance of 3 between them, right? So that's what we want to do in this case, is actually subtract. We just have to make sure that we're getting a positive value for our distance. So you're also going to want to make sure you take the absolute value just in case it comes out negative, right? I'm going to do absolute value 3 minus negative 13. Now, the order of this really does not matter, okay, because the distance one direction versus the other is still going to be the same as long as you're taking that absolute value. Now, that's just the distance from 0 to 2 seconds, though. I also need to factor in the distance from 2 to 3 seconds, since that's where I'm trying to end up. So we also need to know what's our position at 3 seconds. I'm going to substitute 3 into my position function here. And what should that give us? Good, that's going to be negative 6. And so now I need to know the distance between 2 seconds and 3 seconds. So what am I going to do to find that? Good, subtract again. This time I'm using the 2 and the 3 here. So it's going to be negative 13 minus negative 6. Again, the absolute values will take care of the fact that these might come out negative, but distance should be positive. All right, so if we do 3 minus negative 13, what's that going to give us? Good, that should be 16 for this one. Plus, and then negative 13 minus a negative 6 is going to give us negative 7. Taking the absolute value, though, should give us 7. And now if we add together, what do we get? Perfect. 23 is the total distance that's traveled in this case. And again, we cannot just look at the starting and ending positions because there is that change in direction. So we have to factor that in when we're calculating that total distance now. Okay, I don't think I gave you anything. I think this one's ambiguous. Yeah, there's no units for our position or anything. So in this case, it would just be a numerical value. Okay. So if I had said, distance is meters and time is seconds or something like that, then yes, put meters on there. But for this one, no units were given. Any questions on that one now? All right, now part D, I'm not going to give you on the test, so you can ignore that. If you want to know, you can look at my solutions. Basically, it's speeding up when velocity and acceleration are both positive or both negative. So you just have to figure out where are both of those functions positive, where are both of those functions negative. That'll tell you where it's speeding up. And if they have opposite signs, one's positive, one's negative, that's where it's going to be slowing down. Okay, but again, we didn't really cover that too much in class, so I'm not going to ask you that on the test. All right, so let's take our break. It's basically 11:04 right now, so 11:09, we'll get started back up and we'll finish the review. All right. So number 6. And we've got the volume of a cube increasing at a rate of 10 centimeters cubed per minute. We want to know how fast is the surface area increasing when the length of an edge is 30 centimeters. All right, so what do you think we need to do first here? All right, so if you want to sketch out the picture, we can do that. All right, so what are we drawing here? All right, good. It's going to be a cube. Draw my cube. Our cubes here are going to have square faces, all the faces being congruent to each other. All right, so there's my cube. All right, now what do we know? Okay, we know the length of one of our edges. So how do you want to label that? What variable do you want to use? A, okay, so we'll call A 30 centimeters. Now, if one of the edges is 30 centimeters, that means all the edges are, right? Because the cube here is going to be all squares. Okay, so if that's 30 centimeters, every single edge in that cube should be the same thing. Now, what other information are we given here? Okay, good. The rate here, and it's the rate of change of what? The volume, right? So this is a rate of change of our volume. So how could we label that? So not dAdt, because dAdt would be the rate of change of the edge. We're finding the rate of change of the volume, so we can call it dVdt. Good. So we'll say that dV dt is going to be 10 centimeters cubed per minute. All right. So what formula are we going to need here? Okay, we're going to need surface area of a cube, right? Because we know we're going to be looking at that. And we're also going to need what? So I don't think we did one with a cube yesterday. So I don't think any of the ones we looked at yesterday are going to help us. So what other formula besides surface area are we going to need? Volume, right? Okay, because we know the rate of change of our volume. So in this case, we're going to use two different formulas to be able to actually find the information that we need, right? So let's start with volume. How do we find the volume of a cube? Length times width times height. But if it's a cube, what do we know about length, width, and height? They're all the same, right? So we called our edge length A. So how could we represent volume in terms of A here? A to the third, because it's just going to be A times A times A. So A cubed. Perfect. Now, what could we do with that volume formula at this point? Good. We need to find the derivative because we know something about the rate of change of volume. Well, what's the derivative of V going to give us? Okay. 3a squared, and this is dv dt over here now. We get 3a squared. But because we're taking the derivative with respect to time, what else do we need to remember here? A dA dt. Good. Just remember, every variable that you're taking the derivative of, we're taking it with respect to time, so you're always going to need that variable with respect to time over there. Right, let's think about what we know, right? So what information can we substitute into that formula now? Yeah, we know the value and we know the dv dt value. So let's go ahead and plug those in. So dv dt is 10. We have 3 times a squared. That's going to be 30 squared, which means we can actually find the dt now. Okay, so if we simplify the right-hand side here, what's 3 times 30 squared? 2,700. Good. Now if we divide to get dA dt by itself, what's that going to give us? 1 over 270. All right, so that's our dA dt. So that represents the rate of change of the edge with respect to time. We want to know how fast is the surface area increasing when the edge length is 30 centimeters. So what are we going to need to do now? Okay, good. Find the surface area formula. So how would you find the surface area of a cube? Perfect, right? So we know the area of one of our faces is just going to be a squared. We know there's 6 faces on a cube that are all the same. So this is just going to be 6a squared. Now, we want to know how fast is that surface area increasing. So what are we going to do with that surface area formula now? So if we're looking for how fast the surface area is increasing, we're looking for, so we can't substitute anything yet because we're not looking for an actual surface area. We're looking for the rate of change of that surface area, right? Since we want to know how fast, we need to know dA, big A, dt, right? So it's going to be dA dt. And then what's the derivative of the right-hand side going to give us now? 12a. But again, because we're taking the derivative with respect to time, we got to have the dA dt over here now. So notice the little a represents edge, right? And the big A represents that surface area. Now we can substitute, right? Because we've got all the information we need to plug in to figure out that rate of change of that surface area. So we're trying to find dA dt. We substitute in now. We know the A value is going to be 30. We calculated dA dt as 1 over 270. And so what is the rate of change of our surface area going to be now? Almost. You got an extra 0 in there. 4/3, right? Okay, so 4/3. Right, and then what would our units be on that rate of change? Okay, almost, right? So remember, this is a rate of change of a surface area with respect to time. Centimeters squared per minute, right? So this is going to be centimeters squared per minute. Remember, the volume was changing at a rate of centimeters cubed per minute. The edge would be, this one would be centimeters per minute. But now the area would be a rate of change in centimeters squared per minute. Okay. And that's our answer, right? So we were trying to figure out how fast is the surface area changing, increasing. 4/3 centimeters squared per minute would be our answer. So this is one where you technically need two different formulas, right? Because we're dealing with volume first, that's what's given. We're trying to find rate of change of surface area, so you need both of those formulas. In both cases, though, you're going to take the derivative, find those rates of change, substitute everything in that you know, and then just plug in to find that rate of change of your surface area once you have everything you need. Any questions on that one now? All right, number 7. So a balloon's rising at a constant speed of 5 feet per second. A boy is cycling along a straight road at a speed of 15 feet per second. When he passes under the balloon, it's 45 feet above him. We want to figure out how fast the distance between the boy and the balloon is increasing 3 seconds later. Okay. What do you want to do first here? Perfect. All right, so let's sketch this picture. Think about what's going on. So what's one thing that we can put in our picture? Okay. All right, so it's going to look like a right triangle, right? Because we're going to have a balloon that's rising. That's going to be a vertical line. We're going to have a bicycle along the horizontal, right? So basically, balloons moving like this, bicycles moving like this. Right? And so we can put our balloon up here, and then we can put our bicycle. Again, apologies for the poor art. Okay, but that's the best I can do. Okay. So there's our bicycle, right? So the bicycle is traveling off in this direction like this, and the balloon is rising up like this. Right, now let's think about the information that's given. What do we know? All right, so we know something about dAdt and dBdt, right? Because we know the rates of each of those things, right? So if we call this side A and this side over here B, think about the rates of each one of those now. All right, so what's our dAdt value going to be? That's the 5, right? So that's the 5 feet per second that the balloon is rising. dBdt is going to be what? That's our 15, right? So the bike is traveling at 15 feet per second. Okay, so we know those. What else do we know? Okay, yeah, so they are perpendicular, right? Since one is rising vertically, and that's how we're going to get this right triangle that we can work with. All right, so the balloon is 45 feet above him. When is the balloon 45 feet above him? As soon as he's under it, right? So when he's at that point directly below it, that's when the balloon is already 45 feet above him. Well, he's been traveling for how much longer now? Three more seconds, right? So A in this case is going to be 45 plus however far it's traveled in those extra 3 seconds. How can we figure out how much further the balloon has traveled now in those extra 3 seconds? So not 15 divided by 3. Okay, we're going to add 15. Why did you add 15? Okay, it's rising at a rate of 5 per second for 3 seconds, right? So that's going to be 5 times the 3. Okay. Yeah. So he travels at 15 feet per second, right? But we're talking about the balloon right now. The balloon is rising at 5 feet per second. It's doing that for 3 more seconds, so it's going an extra 15 feet at that point. So when we add this together now, 45 plus 15 should give us 60, right? So our A value over here now, the balloon's actually going to be at a height of 60 feet total. So just be very careful here, right? It was 45 feet when he was directly below it. He's ridden for another 3 seconds. That gives the balloon 3 more seconds to rise at 5 feet per second. So it's really 45 plus 15 is the total height of the balloon now. All right. Now, what about the B value? So where would that bicycle be when the balloon is 60 feet in the air now? Good, right? So we're going to take the 15 feet per second, that's his rate, right? And he's doing that for 3 more seconds. So our B value now is just going to be 15 times 3. And so that total distance should be 45 now. Any questions about how I got any of those numbers that we've got in our triangle now? All right. Now, what are we trying to find? Good. We're looking at the rate of change of the distance between the boy and the balloon, which is how fast is that hypotenuse changing, right? This is what we're looking for. So what are we going to have to use to figure that out now? Pythagorean theorem. Good. All right, so we're going to use our Pythagorean theorem. A squared plus b squared equals c squared, since we have a right triangle this time. What are we going to do with our Pythagorean theorem now? Okay, good. We need the derivative, right? So remember, when we do this, that's going to give us 2a dA dt plus 2b dB dt equals 2c dC dt. All right, so what's the only thing we're missing now that we're going to need to be able to calculate dC dt? We need the c value, right? How are we going to find c? Yeah, we can just plug in a and b into the original Pythagorean theorem and solve for c. So we're going to have 45 squared plus 60 squared. I think I switched those. It really doesn't matter. Okay, equals c squared. Now, if we do that, what's 45 squared plus 60 squared? Good, 5,625. And now if we take the square root of that, that's going to give us 75. And this is really just a 3, 4, 5 right triangle, right? 3 times 15 is 45, 4 times 15 is 60, and then 5 times 15 would give us the 75 there. All right, now that we've got everything we want to substitute in, we can just plug in here. So we're going to get 2 times our A value, which is 60, times our rate, which is 5, plus 2 times B, which is 45. dB dt is 15. And then 2 times 75. And we're looking for dC dt. All right, so just go ahead and simplify what's on the left first. So if we multiply and add all that together, what's that going to give us? Okay, 1950. And then 2 times 75 should just be 150. And so if we divide there, what's that going to give us? 13. Good. 13 is our dC dt value. Now we just need our units. Okay, so what are the units going to be on dC dt? Perfect. Right. That's a rate of change of that distance. So that's going to be in feet per second. So again, it's a right triangle problem. That means Pythagorean theorem. We have to find the derivative, plug everything in that we know. The tricky piece of this one, right, is really figuring out what those A and B values are just based off of the wording of the problem, right? So in this case, it started 45 feet above him. It's done another 3 seconds beyond that. So that's another 15 feet. So that gives us a total height of 60. Same thing with the bike. He's been traveling for 3 seconds at 15 feet per second. So he's actually going 45 feet at that point. Any questions on that one now? So using degrees, like and actually like using a theta value instead, is that what you're asking, Paulina? And actually thinking about the angles instead? Um, We don't need to here. Honestly, if you did that, what would happen? You would be going from side length measures to an angle measure, and you're going to have to go back to the side length measure since that's the thing you're trying to find. The only time I would say you really need to use a theta and think about the angles is if you're actually looking at a rate of rotation of something, like the spotlight problem that we did yesterday. That's the only time I would ever use a theta, because otherwise, if you're just looking at the relationships between the lengths of the sides, it's like an extra step that's just going to add more work that's not really necessary because you're going to go from one to the other and then back to the other anyway. Okay. Any other questions there? All right. Now, number 8 is linearization. It's going to be an extra credit problem on the test, so there will be one extra credit. It's section 0.9 if you want to look at it, right? We didn't cover it, okay? But if you want to look through it, look at my work on the solutions of the practice test, feel free. I'm not going to go through it right now, right? Because it takes some time to actually teach that, and I'm not going to be able to do it in 15 minutes anyway. That's why I skipped that section. So if you want to see how to do it, it will be an extra credit. Feel free to do it. Okay. And if you've got any questions, let me know. But I'm going to give you these 15 minutes back. Feel free to use them however you feel you want to. Work on homework, send me questions, whatever you need to do. I'll hang out here too if you do have any questions. I can answer those. Okay. But otherwise, that's all we're going to cover today. Again, test will open at midnight tonight. It'll be due Friday by midnight. Section 2.8 homework due by Thursday at midnight. So make sure you're working on that. Let me know if you've got questions. Have a great afternoon, and I will see you all tomorrow.